And we are here today at the lovely Hilton Anatole Hotel in Dallas, Texas. This is EarthX 2026. We've been talking to all sorts of innovators, people who are on the cutting edge of making a difference for creating a sustainable world. And right now I've got somebody who has been running all over the place, and she just decided to make a little bit of time for us here at EarthX. And this is my friend Manisha Priyadarshini. And she is doing some amazing work when it comes to the ability for AI to quantify the natural world. And when we talk about making sure that we have data that is viable, she maximizes ROI and a whole bunch of other stuff. So tell me about the work that you're doing, Manisha, and about Circle Day America.
Theo, it's an absolute pleasure to share the experiences from all of the learning we've done at Program Earth for the last 7 years, quantifying, talking to communities, and really covering data sets that we like to call AI as an ancestral intelligence.
Oh, well, let's go ancestral intelligence. Okay, I like that.
So a lot of what I spent my time at GitHub, which was the co-pilot for developers and the AI for developers, was helping CTOs quantify the ROI because of the productivity happening when we have large swaths of developer behavior informing AI. And what we noticed was when we were able to take 110 million developers' behavior, our AI got more sophisticated.
Yes, it would.
And what we noticed in the nature space was that AI has a hallucination rate of 17 to 40%.
Hold on. No, look. First of all, I don't need my AI hallucinating. I need you to break down to me, what does it look like when you find out that AI is hallucinating? What does that actually mean when it comes to the data that you're acquiring?
So what that means is watershed management plans are inaccurate, and people might not find that out until 2 or 3 years down the line.
Yikes.
Or it means that agricultural plans are not actually optimized for that particular ecoregion.
Okay.
And so with that, we decided to take the question to people who have been observing nature the longest, who have been stewarding biodiversity in the largest scale, and that happens to be indigenous communities.
Shout out to indigenous communities. Yes, ma'am.
And indigenous communities steward 80% of the world's biodiversity. And so what began as simple data visualization of showing the impacts of how reforestation can be accelerated by 3 times, or wildfire mitigation can be de-risked by 50%, slowly became part of a larger pipeline to inform AI models for water quality divisions for different states.
Gotcha. Okay, no, so literally you're doing the actual real data, the raw data that lets us know if we're being effective at all. And so I kind of want to know more about your organizations, because you told me about the parent organization. Is that the parent umbrella for Circle Day America? Like, tell me what these words mean.
Yeah, so Program Earth, it definitely sits on the advisory for the larger Circle Day America organization.
Okay, so that's a large organization, and Program Earth is the one that you're more directly in charge of.
Correct.
Got you.
Yeah, and so Program Earth, if I were to give a one-liner, we work on different nature-based solutions being modeled through AI by indigenous communities. And we do that in the United States, in Brazil, in India. And really there's what we realized is a lot of the data sets that a lot of nature AI models are missing are from indigenous communities. And they cover some of the most remote regions in the world. And at the same time, remember the relationality of the data. So a really cool example that we were able to uncover in California with the Klamath River was, so the California Water Board was like, okay, we think we need to dredge some of these wetlands because they're contributing a lot of methane into the air.
Okay.
And that sounds like a really good idea, right? Like they're these huge like producers of methane, we should dredge them, no more methane. However, nature is not very linear. It's actually very cyclical. And so the Hoopa communities quickly informed us that the wetlands are actually where salmon spawn.
Oh,
And the thing about salmon is they also return end of life exactly where they spawned.
wow.
And when they come back, they're coming back with marine derived nutrients like nitrogen and phosphorus. And the land there and the native plants there that are fire resilient are actually waiting for the salmon to come back.
Oh, wow. So basically, what you did was you stopped people who wanted to be do-gooders and talked to the people who actually know how to do good.
And turns out doing good is $110 billion of wildfire resilience.
Wow. In California, I think that will be very much appreciated.
And so, originally the plan that was proposed was stating that they would be, getting back $4 to $6 billion a year
Yeah.
for the next 10 years. And so quickly that math became, do we want $110 billion worth of wildfire risk? Or do we, want to make an additional 40 to 60 billion, again, very much up in the air. And the math turned out that we keep the wetlands.
Yeah, as we should. And see, I've heard about nature-based AI models before. You're the first one to tell me that they were not being informed by the wisdom of indigenous communities. So thank you for remedying that gigantic hole in the data set, because I know that we need their input for sure. And so now I just kind of want to ask you, how did you get into this? What was your path in being like, okay, now I want to actually figure out how to use my skill set to help the environment?
I think, like all great stories, our grandparents can be part of them.
Yeah, mine as part of mine, yeah.
And some of my earliest memory is my grandmother, who is a Santhali woman, Santhali indigenous woman, who told me that, my nickname is Mona. So she was like, Mona, we'll know that the world is in trouble if we value our sal grove more when it's cut down than when it's standing.
Wow.
And she was talking definitely to how the sal tree is pertinent to our mangroves and the marine life, but also it's the sacred tie in many of our ceremonies, whether it's marriages, whether it's graduations. And that is a reminder to value nature as if we are also nature. And so a lot of that, when we go looking at nature-based modeling for AI, is how do we keep that continuity?
Right.
And how do we sustain, right, not just a immediate outcome, but how are we making models that could sustain for generations?
Yeah. Okay, so basically, you've been on this path all your life. Like, since your grandmother told you that bit of indigenous wisdom, I'm sure that set your viewpoint and kind of let you know what to look for. And so what was the catalyzing event to have you join and then be ahead of your organization that you are now?
Yeah, so Theo, I like to think that our life is a mosaic leading up to our purpose.
Yeah.
And so I actually was in climate policy. Once I got out of college, I was like, all right, climate policy is it for me. And
Is
then
that what you went to school for?
I actually went to school for engineering.
Okay.
And I used to do debate. And so then somehow got into climate policy. And then realized that it's not enough to tell people what they can't do. We actually need to build those alternatives.
Got you.
And from there, I went to Microsoft. I was helping inform public sector agencies, how they can smoothen that civic engagement, their own AI workflows. And then I realized that as I was helping all of these agencies really visualize the data that helps them inform those decisions, that was when I realized we don't have enough of that bioregional ecological knowledge that are informing our public sector agencies until we figure out a way to bridge that with tribal nations.
Got you. So tell me, like, what is the difference between like the bioregional data sets? Like, I think I know what that means, but I don't really know what it means until you tell me.
Yeah.
So what is bioregional data?
So bioregional data is, I like to give it in examples, but like bioregional data is essentially observations of patterns between nature for millennia. So it's like the relationships between plants and animals and climate risk events. It's the relationship between the soil biome and those plants. All of these interconnections of ecosystems through observed behavior for millennia.
Got it.
And a really quick example I can give you and how it's super helpful is a lot of times water quality divisions are coming to us because they're looking for nature-based solutions that replenish water.
Gotcha.
And often the monitoring for those solutions can be really expensive to fund because you're not going to see that return of water for potentially 2 to 3 years. And so in these scenarios, what that bioregional ecological knowledge does is, one, it gives us a head start on where is the most strategic places to apply remediation. Two, what are the biodiversity indicators to know that things are working and are good to go to monitor?
Right.
And then three, what are the compositions of the solutions that would be the most effective?
Okay.
And usually these things could take years and years of research. But, for example, the Ute Mountain Ute in San Juan County let us know that if we were trying to do replenishment for the Colorado River, we would have to start with the San Juan Basin because that contributes 50% of the sediment to the river.
Wow. So yeah, I was wrong about what bioregional data was, and I'm so glad that I asked about what it actually means. Because, that's why they pay you the big bucks. That's why they pay you the big bucks. What we're saying is that you have expertise and you have a sensitivity to go with that expertise to make sure that you're asking the right questions to the right people. And so now when I talk about, ROI and what projects are you working on in the future, first of all, are you working with more public or private sector?
It's really a mix of both,
Okay.
Theo. In this moment, we're seeing the public sector funding coming through like watershed management plans. And then, we also see watershed management being a priority for any companies that are also dealing with data centers.
Oh, goodness. Don't get us started on that. Yeah, I know that's a big thing. So basically, what I'm trying to figure out is, when you talk about, let's go into the data centers thing, because it looks like AI isn't going anywhere unless it's ancestral intelligence, then of course that's a whole different thing. But what are the challenges that you're finding, because they're getting a pretty bad rap. Not saying that some of them aren't earned, but there is an effort to redeem those efforts that they're putting forth to, perhaps make their water consumption more sustainable. Are you working on that front?
So Theo, it's funny, they're kind of nested together. So yes, for example, a data center, in order to get started, might take the equivalent of 2 Olympic-sized pools. And that seems like a scary number, but where we can be prescriptive is that if we model the solutions of, let's say, reforestation across 1,000 acres, 1,000 acres within a year of reforestation will also produce the amount of water in 1 Olympic-sized pool.
Wow.
So the idea is, can we parallel efforts? So if a data center is being opened, we've also reforested 2,000 acres before that, and then we will have the equivalent of 2 Olympic-sized pools, which is what it takes to open said data center in the first year.
Okay, so that's in the first year. I was like, is that like per day?
In the first year, yeah. And so every year
God.
you can expect an Olympic-sized pool based off of 1,000 acres of reforestation.
Really? So That's something that I didn't know, and I think that, because like I used to be a swimmer, so you're putting these things in context for me. Before we go here, is there any project that like you're really, really proud of that is kind of exemplary of the work that you do?
So honestly, I'm super proud of the work that we've been doing in San Juan County
San Juan County.
because it is close to a few data centers. And, often we think of AI as the problem, but what we've also seen is AI helped model the nature-based solutions needed to replenish that water and create consensus in what would have taken 7 to 10 years to 1 to 2.
Wow. So the very AI centers that everybody is against is also creating the kind of roadmap to make sure that they can be sustainable by working with nature and not against it.
So as much as I would love to, credit AI, I also want to credit ancestral intelligence here.
That version of AI. Big AI, right.
Because without the Ute, Mountain Ute, and the Southern Ute telling us where to put those amendments and also look at which sorts of indicators, we would not have been able to rush to those results in the way that we had.
Oh, wow.
And I think the artificial intelligence AI really helped speed the process in terms of calculating those ROIs, getting all of those briefs and policy, like modeling to the Water Division of Quality, to stakeholders that were like funding the project. But it's a joint effort. And I think, as data centers, continue to increase, I think it's like, how can we make sure it's this coordinated effort,
right,
where let's continue to reforest way before the data center is planned.
Right.
And then, yes, we can use the AI that's being powered by the data center to continue that consensus so that we are able to reforest quickly and with communities.
It is a widespread collaborative effort, but the problems of the future are being solved today, and they can't be solved without folks like my good friend Manisha Priyadarshini. And I just really appreciate the work that you're doing. Please come back. EarthX needs folks like you. The world needs folks like you. Here at EarthX 2026, we're talking to so many wonderful change makers who are really out there doing the work in areas that you can't even possibly imagine, so that we can create the world that we all can imagine. So won't you stay with us? We'll be back right here in the lovely Hilton Anatole Hotel. I'm Theo E.J. Wilson. Stay tuned. Thank you.